Hey everybody, we are going to prove the power reducing formulas for sine, cosine, and for tangent. So we're going to start with sine, but of course this all comes from the difference formula for cosine that we proved last time. Actually, and what we used that formula for was to find the sum formula for cosine, which is where this double angle formula for cosine came from. So we're just using this double angle formula for cosine, and I'm just going to solve this for sine squared. So I'm solving for this expression right here. And when I do that, that means I have to, I'm going to add 2 sine squared and subtract cosine of 2x. So I get, oops, still got the highlighter. So that means I have sine squared of x. I have 2 sine squared of x equals 1 minus cosine of 2x. Then I'm just going to divide by 2. Sine squared of x is equal to 1 minus cosine of 2x divided by 2. And that's it. This is the power reducing formula for sine squared. It's called the power reducing formula because we started with something that was sine squared, and now we have something that is actually just cosine of x. All right. So we're going to do the same thing with cosine squared. We're going to use the other double angle formula for cosine, which is 2 cosine squared x minus 1. This one's a little bit easier to solve for cosine squared x. That's our goal, is to solve for this. So I'm going to add 1 and I'm going to divide by 2. And so I get cosine 2x plus 1 divided by 2 equals cosine squared x. And this is the power reducing formula for cosine. And then for tangent, tan squared x is sine squared x over cosine squared x. And we know the power reducing formula for sine squared x is 1 minus cosine of 2x over 2. And for cosine, it's cosine of 2x plus 1 over 2. The 2's cancel. And so I'm left with 1 minus cosine of 2x over 1 plus cosine of 2x. And this is the power reducing formula for tangent. So now here are the formulas typed out in case you don't like my handwriting, which I don't blame you. But we are going to now apply this to find an equivalent expression for the cosine to the 4th power of x. That contains only first powers of cosines and multiple angles. All right. So our first trick is to think of cosine of x to the 4th power, because that's what this really is. It's cosine of x to the 4th power. What we're really going to think about this is cosine squared x squared, which is really cosine of x squared squared. So that makes sense. So we're thinking of this as cosine squared of x squared. Now we know cosine squared of x, this we have a power reducing formula for. So what's in yellow is going to become 1 plus cosine of 2x over 2. But that's still squared, which means the numerator squared, which 1 plus cosine of 2x squared is 1 plus 2 cosine 2x plus cosine squared 2x. And then the denominator squared, 2 squared is 4. Then here I have the power reducing formula that I can use a second time. So that cosine of squared of 2x, so we have the 1/4 out in front. We have a 1 plus 2 cosine of 2x plus this cosine squared of 2x becomes 1 plus cosine of 4x, because I double what's inside. That's how the power reducing formula for cosine works. It happened here. We doubled what was inside. We're doubling it again. Over 2. And so when we multiply out the 1/4, we get 1/4 plus 2 cosine of 2x plus 1/2 plus cosine of 4x over 2. And now if I distribute the 1/4, I get a 1/4 plus 1/2 cosine of 2x plus 1/8 plus cosine of 4x over 8. I can add these two together. That gives me 3/8 plus 1/2 cosine of 2x plus 1/2 cosine of 4x. And now I have, instead of cosine to the 4th, I have only first powers of cosines with multiple angles. So the multiple angles are the 2x and the 4x, but that is my final answer here. Now, I'm not saying this is particularly useful. I'm just saying that we were able to use algebra. We didn't change the value of our expression. All we did was we changed the way it looked. We did plastic surgery on this thing, and we drastically changed cosine to the 4th of x to look like this. And sometimes that's just what we need to do. Maybe the answer in the back of the book looks different from our answer, and we need to know that they're the same thing. Maybe we are just trying to prove that algebraically two things work the same way, and we need to make them look the same somehow. And these are techniques that we would use. And you will use these in calculus. All right, I'll see you in the next video. We're going to prove the half angle formulas, and then we'll be on our way to finishing up. We're going to do some solving of trig equations, and then we'll be done for today.